Hello friends, good morning. I am Professor Ramesh Kende, working as Assistant Professor in KK Waghe Institute of Engineering and Research Nashik. And in this video, I am going to explain you regarding the IP address. Okay, so here IP addresses and the classful addressing system. So one by one, I'm going to explain you about the IP addresses. These are the contents of this video. The first one is the introduction, then classful addressing, and then different network classes. As we know, this is the subject of the computer network, and in the computer network, uh, without the IP addresses, without the IP address, we cannot do anything. So it is very important to study the IP addresses. The first part is introduction. We will see the details of the IP addresses. So here, first of all, we have to study what is an IP address. An IP address is a 32-bit address, and it is having two versions, IP version 4 and IP version 6. Whereas IP version 4 is of the 32-bit long and IP version 6 is 128-bit long. The IP addresses are unique and universal. So one by one, we will see this in detail. This is the address space. In front of you is the address space. The address space is nothing but the addresses are assigned here like this. Address 1, address 2, address 3, address 4, address 5, address 15, address 31, address 41, and address 226. So this is about the address space. Then we have to study the address space rule. Address space rule. The address space in a protocol that uses n bits to define an address, and it is 2 raised to n, where is the n is the number of bits. So here IP version 4 address space, the address space is 2 raised to n, we know the formula, and the n is 32, so that is the 2 raised to 32. So as it is more than 4 billions of the addresses can be assigned. Then we have to see the representation of this IP addresses. IP address is represented by the two methods. The first one is the binary notation method, and another one is the dotted decimal notation. So we will see one by one this in detail. So you can see this is the binary notation. 32-bit address space is divided in 4 bytes. This is the first byte. This is second byte. This is third byte. This is fourth byte. Okay, so each byte is having 8 bits, and the total 32-bit is divided in 4 byte. Then second one is the dotted decimal notation. You can see the first is in binary notation. So here this first byte is converted into its equivalent decimal number, and you can see this is the 128. The second one is again divided into its equivalent decimal notation, and this is 11. This is the 3, and this one is the 31. So 128.11.3.31. It is in dotted decimal notation. So here two methods are used. The first one is the binary notation, and second one is the dotted decimal notation. So what is difference here? In the second one, this is represented in decimal and separated by dot, Hence, it is known as the dotted decimal notation. So 128.11.3.31. Then one more method is there, how to represent the IP address. It can be represented in hexadecimal notation also. So here each byte is converted into the hexadecimal and then it is represented in the hexadecimal. So you can see here, this is the 75951DEA. It is represented in the hexadecimal notation system. Then we will see some examples. The first example is given here. This is in front of you, and they have asked change the following IP address from binary notation to dotted decimal notation. So very simple method, but you should know how to change it into the dotted decimal notation. As we have studied, dotted decimal notation is nothing but it is converted, each byte is converted into its equivalent decimal number, and it is separated just by the dot. It is separated just by the dot. So here you can see this is the first byte, this is the second byte, this is the third byte, and this is the fourth byte. As we know, binary to decimal conversion, and just we have to put each bit into its positional weight system, that is 1 into 2 raised to 0 plus 0 into 2 raised to 1 plus 0 into 2 raised to 2 and so on. Okay, and finding the positional weight, that will be the equivalent decimal number. So 2 raised to 0 into 1, that is 1, and this is the I think 2 raised to 5, and that is 128. So 128 plus 1, that is 129. Again, the same thing over here. For the second byte, we have to convert it into its equivalent decimal number, that is dot 11. For third also, it is dot 11. And this last byte is again converted into the its equivalent decimal number, and that is the 239. Then second example, change the following IP address from dotted decimal notation to binary notation. The example is vice versa over here. This is the given in the dotted decimal, and then they have asked convert it into the equivalent binary notation. So here the example is 111.56.45.78. So here just we have to convert into the binary. As we know, the conversion of the decimal number to binary by using the repeated division by the radix, and here for binary number system radix is 2, and we have to repeatedly divide this number by the 2, and we have to we will get the equivalent binary number. Then same thing over here. This is the second number is 56, and that is converted into the equivalent binary number. Then the third is the 45, that is converted into its equivalent binary number. Then 78 separately converted into the binary number, and hence this is the total binary representation of this number. Then the example 3. In third example, the example may be like this. Find the error in the following IP address. The IP address is given to you, and they will ask find the some questions may be there. Find the error in the following IP address. So here the address is given 111.56.045 and .78. Okay, so solution to this problem is that there are no leading zeros in a dotted decimal notation. as we have seen the dotted decimal notation, and there we have not seen the number is starting from 0. Okay. Then the one more example. Find the error in the following IP address. 75.45.301.14. In decimal notation, as in decimal notation, each number we have seen that is the less than or equal to 255, and as we know this number in this example, the number 301 is there, and 301 is out of range. 301 is the out of range. Then one more example, example number 4. Change the following binary IP address into hexadecimal notation. Same thing we have did it in the binary to decimal or decimal to binary number. Here this is given into the binary, and we have to convert into hexadecimal number. So each byte we have to convert into its equivalent hex number, and then total number is represented in the hexadecimal. Then next point, we have to study the classical addressing system. So here you can see one graphical representation is there in front of you. That is the occupation of the address space. Okay, so this is the address space. Address space is the this 32-bit, and it is divided in these parts A, B, C, D, and E. In classical addressing, the address space is divided into 5 classes, that is class A, class B, class C, class D, and class E. 5 classes are there, and for the user convenience, it is divided in these 5 classes. Then you can see one more table is in front of you, and in that, finding the class in the binary notation. How to find the class in the binary notation. So here, these 32 bits are divided in 4 parts, 4 bytes. The first byte, second byte, third byte, and fourth byte. Then the 5 classes are represented over here: class A, class B, class C, class D, and class E. Then you can see in the first byte, if first bit is 0, that is class A. In second, in class B, in the first byte, if first 2 bits are 1 and 0, then it is class B. Then in class C, the bits are, starting bits of the first bytes are 1, 1, 0. Then this is the class C. Then in class D, the first bits are 1, 1, 1, and 0. This is known as the class D. And first 4 bits are all ones, then it is class E addressing system. So this is about the finding the class in the binary notation. Okay, this is the standard. We have to check the first byte and the first bits of that, and from that we can conclude or we can find the class of the address. So here you can see how to the method to how to find the class of that address system. Okay, so we have to start from the first bit and first bit is to be checked. You can see this is the decision box, and here the first bit is to be checked. If it is 0, first bit is 0, then this is the class A. If it is not 0, if it is 1, then we have to go for the second bit. We have to check the second bit. And if the second bit is 0, the second bit is 0, then that is the class B, means this is the first bit is 1, second bit is 0, that is class B addressing system. If it is not 0, then we have to go for the third bit. If it is 1, we have to go for the third bit. Third bit is to be checked over here. And if it is 0, means it will be 1, 1, and 0. That is the class C addressing system. If it is not 0, if it is 1, then we have to go for the next bit, means next bit is to be checked. That is fourth bit is to be checked. And if it is 0, if it is 0, means 1, 1, 1, and 0. That is the class D addressing system. And if it is not 0, if it is 1, then we have to go for the checking, means 1, 1, 1, and 1, means all bits are 1, means it is class C addressing system. Okay, so like this, one by one, we have to check the bits, and if it is according to that table, means we can find the class of the that address. Then the next example show that class A has 2 raised to 31, means this much addresses. As we know, in the class 1, the first bit is 0, remaining are 31 bits, and definitely that is the 2 raised to 31 addresses. Then next example, example number 6, in that they can be asked that find the class of the following IP addresses. The example is given over here, and they will ask find the class of the address. So we will take the first example. First example is this one. This is the first byte, second byte, third byte, and fourth byte. And we have to check the first byte. The leading bit of the first bit of this first byte is 0. First bit is 0, hence it is a class A addressing system. Then we'll go for the second example. Second example to be checked. Second example is like this. Here, we have to check the first byte, and first and second bits are 1. The first and second bits are 1, and the third bit is 0. Third bit is 0, hence it is class C addressing system. Okay. Then next one, finding the class in decimal notation. Finding the class in decimal notation. And here, again, same thing, but it is in decimal notation. The 4 bytes are given, first byte, second byte, third byte, and fourth byte. Class A addressing system is from 0 to 127. Class B, 128 to 191. Class C, 192 to 223. Class D range is between 224 to 239. And in Class E, 240 to 255. So here, the range is given for the different classes, and as we know, this range is fixed, it is defined, and if the address is in between that range, then we can find the class of that addressing system in dotted decimal notation. So here one example is given. That example, find the class of the following address. Find the class of the following address. So here the first example is 158.223.1.108, and second example is 227.13.14.88. So solution for this problem. So first we'll check the first problem, that is the 158.223.1.108. And what we have to do, we have to check the first byte. We have to check the first byte. So here first byte is given 158, and we have to check the range given there. We have to check the range given. As we know, the range of the class is from 0 to 127. Second, 128 to 191. Third is the class C 192 to 223. So hence, the first byte number is 158, and that falls between this 128 to 191, in between 128 to 191, and hence the class of that is class B. So 158 falls between the 128 to 191, that is class B addressing system. And second example, 227 to dot 13.14.88. Again, we have to check the first byte. The number is given 227, and this 227 falls in between this range, that is the 224 to 239. 227 is between 224 to 239, and hence it is class D addressing system. Okay, so like this, we can find out the class of that address. So here we have seen in this video, that is the IP addressing, what is meant by IP address, then IP address space. Then we have seen the two versions, IP version 4 and IP version 6, whereas the IP version 4 is of the 32-bit long, IP version 6 is 128-bit long. Then we have seen the representation of the IP address. It is represented in the binary notation as well as dotted decimal notation. Then we can find out the class of that IP address. The 5 classes are given. We have seen the class pool addressing system, in that the 5 classes are there: class A, class B, class C, class D, and class E. And we learned that how to find out the class of this each address, given address. So like this, we have learned the IP addresses, then its representation, and then class pool addressing system, and some examples. So thank you.